So IoT is essential to an evolving paradigm in our world. It's everywhere from connected cars to smart buildings to smart factories and so on. Companies are trying to understand how they can leverage IoT, edge, cloud, AI, digital twins to identify the right solution based on the requirements and technical capabilities to gain real-time visibility for remote monitoring and predictive maintenance, and to optimize operations and catch issues before they turn into problems. So as you move forward with your journey and you decide you want physical insights into your business operations through IoT solutioning, you need to determine the path to get there, which is based on your requirements and technical capabilities. Should you buy a solution or should you build yourself? It's an interesting question to answer. Now, well, that depends on how much investment you want to do and what kind of capabilities you want out of the box. You have two options on Azure. So you want to use ready-made solutions, no code, low code stuff. Go for IoT Central or time series insights or a partner solution. You want to build your own solution, want to have a deeper control on different parts of the solution, use combination of PaaS services. In this session, we are going to discuss one of the pattern to build IoT Analytics solution with Azure Data Explorer, which makes it really simple and easy to do that stuff on Azure. So this is our reference architecture. Again, there's a lot of boxes and services. Doesn't mean that you have to use all of them, but this gives you a option. This gives you a demonstration of what is possible and how. Okay, so details of this reference architecture is available on our documentation site. The link I've put it on the bottom of this slide, and we'll also share it at the end of the presentation. So in short, you can use Azure Data Explorer as a big data analytics store for serving near real-time analytics, where you can leverage built-in machine learning and time series capabilities, and the data is cached, indexed, and compressed, available for querying. You can get deeper control of your data sources. You can get deeper control on your data lifecycle and cost. You can directly stream your data from IoT Hub, Event Hub, Kafka, Blur Storage, or ADLS into Azure Data Explorer, both in streaming and batch mode. I know under 10 seconds latency or about 10 over 10 seconds latency, there are different options that you can use based on your scenario. And you can store the data in Azure Data Explorer, which is indexed, compressed, and available for querying immediately in near real time. And on top of that, you leverage all rich ecosystem that we have to offer for you to query that data interactively, build dashboards, use Power BI, Grafana, and other connectors and SDKs that we have to offer for you to build automations. And finally, leverage all the rich capabilities and connectors that we offer to hook up with the rest of the ecosystem to build an end-to-end solution. Let's look at what Azure Data Explorer is. It's an interactive analytical service for fast-flowing data. It's an fully data analytics. You can build multi-tenant, single-tenant SaaS solutions for IoT time series, log analysis, events, transactions, security data, and so on. You don't have to manage any infrastructure. There is no index maintenance. All data is compressed and indexed by default for you. It helps you democratize your data with the intuitive query language called Custo query language, which is optimized for time series and log kind of scenarios, and it provides expressiveness and power of SQL within simplicity of Excel. You get instant big data near real-time insights over data in petabyte scale in near real time. Azure Data Explorer is a distributed system with compute and storage that can scale independently, enabling analytics on petabytes of scale. And it's a proven technology. Microsoft uses this internally from many years, and this is the same service that we are offering you to leverage in your scenarios. Let's look at a quick demo, and we're going to focus on demonstrating the capabilities which are relevant for IoT analytics and time series. In this demo, we're going to look at some demo data sets and demonstrate how you can use time series capabilities and other capabilities that Azure Data Explorer offers, which will help you in your IoT analytics solutions. So in order to get started, you need a cluster, Azure Data Explorer cluster, you need a database and create tables and load your data in. There are various ways you can bring in data. through Event Hub, IoT Hub, or blob storage, or push through SDKs. Now, in this case, I have my demo cluster, which I already created, and I've created occupancy database with a bunch of tables and functions that I've written. So the scenario is I have thermostat data, sensor data that is streaming in constantly um, into an event hub, and from there it's flowing into Azure Data Explorer using our built-in integration with Event Hub. Now, once the data comes in, I'm getting multiple events from my source. So I wanted to filter those events, and I want to transform some of those events, and then put them in a structure where it's easy for my users to query. So the data first lands into a table called stage IoT raw data. Let's look at sample data that's coming in. So this is the data that's coming in into my database and has different type of events, and they have different type of schemas. We're going to focus on one of the schema that I'm interested in, where I'm getting this battery level, humidity, temperature, and those kind of sensors. So I wanted to transform this data as it is arriving into Azure Data Explorer, and then make it available for querying. So for that, you can write a function and put your logic in the function. In here, I'm reading it, filtering it, and then extracting some of the values from the JSON, and configure this as an update policy, which is like an insert trigger. And once new data comes in, this function will be executed, and the output of that function will be stored into another table. In our case, it's thermostat table. Now let's see how the data looks like after transformation. So this is after transformation that it looks like, and this is all happening as the data is arriving into the system in smaller batches. So every batch is processed separately. Now you can see that the query that I'm using here is called Custo query language. Very simple to use. You start with the table name, pipe it, and then the IntelliSense will actually guide you with the syntax. And the syntax that is going to recommend are based on the context of the query that you're writing, and based on what columns you have, and so on. Very rich in improving the productivity of writing queries. So let's deep dive into the data. So in this case, I'm looking at thermostat data. I want to query last 7 days of data for a device and get an average temperature by 1 minute window. Okay, let's run this. In just few seconds, I have all my data for last 1 minute. 1 minute for my 1 minute resolution. If I want to change the resolution, it's very easy to just change it here. Now I'm going to do it at 10-minute resolution. And you can zoom in, zoom out in your data, as you are investigating. The aggregates runs on the fly and really fast. Now, let's say I want to identify if there is missing data in my environment. So for that, I can leverage make series capability and convert my data into a time series data set. So in this case, I've converted my data into time series data set. So wherever any value, it is marked as 0. And you can, of course, control the default value that you want to show. And now I see there is some missing data that I'm not receiving in some of the cases. So I understand this is, I understand the scenario. So, but I want to handle this missing data, make it clean so that I can use it in further analysis. So for that, I can add additional line here with series fill linear. Now it's going to identify those gaps, fill those gaps with linear interpolation, and then I get a smooth chart now. And there are more ways you can do it, fill linear, backward, forward, and so on, depending on your requirement. Now, further developing on the same story, I want to understand what's the forecast for the next 15 minutes. So again, I keep on extending the same query with additional pipe here and operators. And now I'm going to use series decompose forecast, and let's run this. And then now I have a forecast for like next 15 minutes. All these are built-in capabilities. You don't have to be a data scientist to use it. They're available in the system. These are the very common scenarios that we see our users are doing with time series data. Doing forecasting, anomaly detection. The next one is on the anomaly detection, where we are using a different operator called series decompose anomaly, and then finding anomalies in the system, and you can fine tune the thresholds for your requirements. And the next query that I'm showing you here is actually going across all the devices and then understanding where all we are seeing anomalies, and then flagging those anomalies for my query, and then I can take this and take actions. So I just showed you a quick demo around time series capabilities. There are more capabilities that you offer, and I encourage you to look at the documentation. Now, These are all the ad hoc analysis. You can take this and create dashboards. You can be very easy. So let's say you want to create a dashboard from here. It's easy to go share, pin to dashboard. Once you pin it, it's going to appear on a dashboard. I'll quickly show you how the dashboard looks like. So these are the same queries that I'm converted them into a dashboard, and you can create a rich dashboard which is built in here, and it's pulling in live data as you refresh it. And once you see certain pattern, let's say you see certain pattern here, you want to drill down into the query, you can easily go and go into the exploration mode and then query the data, change the queries and play with it. Amazing experience to go from an advanced user to reporting experience to an advanced user. Now let's switch gears here. So these are all the ad hoc analysis that we're doing on the raw data, but there are many scenarios where you want to pre-aggregate data by hour, by day, or so on. Traditionally, you have to go and write external jobs to do that and say persist that data. But we have recently introduced a new feature called Metallized View, which enables you to do that. So we define the Metallized View. I'll show you an example here that we have. So these are the two views that we have created. So essentially the first view that it's doing is summarizing all the average of different sensor readings that I have by 1 hour window. And this keeps running in the background, and I have a persisted view where I can go query. So when I query this is actually giving me the pre-calculated data. As well as there are other scenarios where you want to know what is the last value that a device reported. So for that, we have an operator called argmax, which we are using in the second materialized view. So I'll show you the query here. So we are summarizing different sensors that we want, and we are using argmax to actually get the latest record for a specific device. And then we're maintaining that view that has the latest information about the device. So these are very common scenarios that you come across. Now, the thing I want to talk about is in Azure Data Explorer, you cache all your data so that you can get a faster query performance. But there are, for compliance reasons, you may want to archive data onto a data lake for a long-term retention. So in that case, you can set up a continuous export job and constantly export data out of Azure Data Explorer into data lake in a Parquet format, which is partitioned and so on. And then when you come across a scenario where you have to go query that, you can actually use the external table feature and then query that old data. So in this case, I've defined an external table. So it's the same schema. And in here, I want to go and look at some data which is back in March, a couple of months old for a specific device. Let's run this. So in this case, nothing is cached on Azure Data Explorer. As we run query, it goes to the data lake, filters out the data and gets this information to us. So it helps you have built a system which is like a multi-tier, where you have data in cache, you have data in cold store, you have data sitting in archive, and then it's all accessible through different ways. So these are the common ways we showed you. And then there is some accessibility stuff that you can do in Azure Data Explorer with Python plugin. So in this case, if you have some advanced algorithms outside of our platform and you want to use from open source Python packages or something, then you can write your Python code and embed it into the query and run it. In this case, I've embedded my Python code into a user-defined function and just expose that user-defined function to my users. So the users don't have to worry about the complexity that's behind the scene. In this case, the Python is running on the local instances where the data is. So the first few lines actually goes and queries the data, and then we send it to the Python sandbox, which is on the nodes, and then we get this results within a few seconds. So the data didn't move out of the nodes, it's running on the same nodes where the data resides. And also Python plugin is capable of handling distributed algorithms and distribute the workload across multiple nodes. So this is an unsupervised kind of a learning kind of scenario, but you can also bring in your model and store it as a string in one of the table and load it at runtime using Python and then score it. So in this case, I have another user-defined function where I can do a scoring. And again, to user, this is the only thing that is exposed, and they don't need to worry about complexity. And so in this case, the scenario is you have a model which is already trained on historical data, and now you want to score it on the latest data that's arriving into the system, and then I picked 15 minutes, and then we just got this predictions back from the model that was ran. So again, I showed you a quick demo about capabilities, and we have more to cover in this session. You will see how our customers are actually using this in their real scenarios. Now let's see this in action. Let's hear from David and Sherif on how Hilo is leveraging Azure Data Explorer to power its smart grid service and helps its consumers save energy and help the local utility company manage electric demand.
Thank you, Minaj. I'm David from Hilo.
Sharif Zaroubi from Axceta.
And today we'll be discussing how ADX can help us in the energy space. So Hilo is a startup focusing on the smart grid and energy efficiency. We offer solutions to Hydro-Quebec. Hydro-Quebec is the state-owned utility here in Quebec, and the fourth largest hydro producer in the world. Hydro, as all of the utilities, has a demand-side problem right now. Demand is outpacing production and outpacing infrastructure investments. And this is something that's a real challenge. But fortunately, we have technologies today in the 21st century to address this. We did 40 years ago. In Hilo's mind, controlling energy consumption is about creating an ecosystem of devices. And if I take a concrete example of what problem we're trying to solve, if you try to visualize a typical day during the winter here in Quebec, it's very cold. You have two electricity consumption pumps during the day, one in the morning and one in the evening, where people take a hot shower, use their appliances, they'll charge their electric cars, and you have industry also consuming at the same time. So this creates a huge stress on the infrastructure, requiring the utility to invest massively in new transformers, power distribution lines, auxiliary gas, import produced of the year. How do you control more efficiently? How is it that allows smooth and play peak time work simply change user's behavior? Well, at Hilo, we built such a system, both in the residential and in the commercial and institutional space. In the residential space, it takes the form of an ecosystem of devices, smart thermostats, connected water heater controllers, and car charging controllers as well. And in the commercial and institutional space, we have the same types of technologies, but the control mechanisms are a bit different. It's industrial controllers instead of being things that we produce ourselves. But in that space, we have also fleet electricity, we can solar, we can integrate battery system, all of this to help us orchestrate the best energy product respond to specific demands in pseudo real time. If you look at the implementation of this, we call it a virtual power plant. It's basically an ecosystem that allows you to leverage all of the different data coming back from the IoT devices to make informed decisions as to how you should curtail demand in each space. And to do that efficiently requires very large amounts of data coming in, being processed and being crunched and being converted into IoT strategies in a 1 to 2 minute time span in order to fit the curves that we're looking for. Our technology needs to scale to achieve this. We're looking at 200,000 connected houses in about 4 years. This represents 5 to 7 billion data points a month coming into the system. So that's quite a large amount of data coming in, and we're not even talking about the control going out. To support this efficiently, we need to understand the cost, how it scales. We need to understand the performance constraints, and we also need to take a hard look at the cybersecurity aspects. We distribute electricity not only in Quebec, but also in Ontario and the northeastern US. So any breach there is going to have a huge impact. And we'll talk a little bit with Sherif about how we chose the technology and why it's something that has scaled for us up to now.
Perfect. Thank you, David. One of the points that wasn't mentioned really, but that's still a very important factor in our decision-making process was the speed at which the team grew. I think we grew from 2
to 60 in 8 months.
in 8 months. So a lot of fresh faces, a lot of new people, a lot of competent people joining the team. People that we didn't necessarily want to train on, what's the best way of scaling an Elastic cluster, or what's the best way of scaling a Kafka cluster. So one of the key decisions that we made early on in the project was we wanted to go PaaS over self-managed. We did not want to worry about the platform. We really wanted to be able to focus our energy on the business value and on the application layer. So we like to say we didn't want to limit ourselves with the tools that we can operate. We want to limit ourselves, or we want to use the tools that can help us innovate as fast as possible. So the first questions we figured out that we need to ask ourselves, well, what do we really want from a technical perspective? And assuming that our IoT pipeline is already drawn out, installed, running, that we've done the security aspect of it, and that we've done all of the scalability around it, we realized that we had two data stores that we had to worry about. The digital twin, which is more of a real-time, low latency, key value type of system, versus an analytical store that holds all of the historic values. That's more of a time series types of queries that go in, and that receive a low number, so not that many queries, but pretty large queries at the end of the day. The types of queries that we were throwing, that we're thinking of throwing at it is, like something like, give me the 95th percentile of the instantaneous power consumption for all the devices, grouped by time code for all of the zip codes, by zip code group, for all of the zip codes within a given geographic region.
That's a mouthful.
Grouped by 1 minute time. I mean, try to do that in SQL. I think you will require a bit of therapy on that one. But you see the sequence of filtering, grouping, sorting, filtering, and grouping, and summing and calculations. It could get in there. But more seriously, the types of requirements we were looking at least on peak writes, we're looking at 3 million events being injected. It's okay if there's a bit of latency, not too much, but if we can drop it to sub-minute, around the minute, we're okay with that. The reads were a lot less sensitive, so we didn't really spend too much time there. Regarding another key aspect of it is the developer experience. So we wanted something that is easy to use, easy to integrate into, something that you can write easily into. A querying language that's not too foreign or abstract, not too funky or weird. We also wanted a tool that we can operate, or at least have observability into, so something that has metrics that are live and easy to use, and all of that. From a security perspective, row level, column level locking, resiliency is very important. Data governance, so data sovereignty in Quebec or in Canada, very important. And last but not least, the cost could not be astronomical. We're still a startup within a big entity, but still a startup with startup budgets. The solutions we looked at, just for you quickly here: ADX, Cosmos, Elastic, Postgres with Timescale, Apache Druid, and Prometheus. So why did we choose ADX? Well, it's a no-touch operation tool, so we don't have to worry about sharding or replication or index management. Really, write data, query it. That's pretty much it. The query language, the KQL, is very adapted to what we're trying to do. Blazingly fast, magically fast. I think the engineers must have thrown some pixie dust at it to make it run faster. I don't know. It integrates with the rest of the system, and so on and so forth. There's many good reasons to use it, or at least many good reasons why we chose it over the competitors. Some of the drawbacks or some of the learnings that we had was, KQL is a new language with its mindset, but if you're familiar with the way that the Unix pipes work, many small operations piped into the next one, and so on and so forth, it works well if you already have that mindset. If you don't, you have to undo a bit of that SQL and procedural reflexes that some developers have. Another, I think, point worth mentioning is the CI/CD. There are tools that exist to integrate with CI/CD and to auto provision, but they're a bit clunky, especially in dynamic environments that we have. The demo gods have mistreated me a few times in the past, so we have a few screenshots here that I'd like to prepare for you, and it's a real use case. So we got calls, low latency was noticed on the system. We didn't get any alerts. How come we didn't get any alerts? So at at like 3 o'clock in the morning with the stress of production, we came up with a simple to use query that we can plug into our monitoring system. So the following query that we're going to see goes back 30 days for all of the telemetry points that have been shipped to our system, computes the latency on the fly. Based on the latency, it buckets them in 15-minute windows. It gets the 95th percentile of it, and then it calculates and it tries to detect the anomalies within there. So about 30 days worth of data, 5 seconds compute time, very simple and easy to read query. I mean, I try to do that in SQL again, therapy. All the red dots that you see are the anomalies that have been detected, and all with visualization aspect of it. Side note: it takes about 20 seconds to load CNN.com on a modern browser with a fast internet connection, but 30 days worth of data with anomaly detection in 5 seconds. So if you have any questions, don't hesitate to contact me or David.
Absolutely.
Our
Feel free
emails
to
are
reach
there.
out. And thank you so much for being here today. Back to you, Minaj.
Thank you, David and Sharif, for sharing your journey. It's exciting to see how you're leveraging Azure Data Explorer to build your IoT Analytics solution for managing energy. Sharif, I liked your filter group by example. I'm glad that Custo query language is simplifying your analytics. Thank you for sharing. Now, as you move forward with your IoT journey, you may want to create living replicas of your physical environment, model your connected devices, and run analytics on that. Let's hear from Tyler on how Azure Digital Twin can help you model your real world. Tyler?
Thanks, Manoj. I'm Taylor Anderson. I'm a principal program manager with Azure Digital Twins, and I'd like to start off by talking about what is a digital twin. And a digital twin is really a digital replica of real world things. I think a lot of folks, when they think of digital twins, think of modeling assets, tangible items, but digital twins can also be used to represent places or even business processes or people. And what we're seeing is that as customers move through their IoT journey, a lot of folks are starting off by connecting individual assets to the cloud to gather telemetry or be able to issue commands to those devices and assets. But what we're seeing is an interest in connecting multiple assets together to understand what's going on within an entire environment, to really derive additional understanding and business value from how those environments behave over time. And where we see this heading further out into the future is customers taking those environments and connecting those environments together to form connected ecosystems. Now, what kind of verticals or industries are great candidates for modeling as connected environments? Well, turns out there are a large number of them. So for example, manufacturing, the ability to model a connected environment, a manufacturing line, for example, within a plant, or to model the supply chain that feeds material to that plant, or looking retail operations, again, looking at modeling activity within a store, modeling product as it moves through that store. I think real estate is a classic example of a connected environment with smart buildings. Modeling a building as a selection of several floors with rooms on each floor, and then different devices or sensors within each room. So for example, occupancy sensor or temperature sensor, or thermostat. Moving through other verticals as well, healthcare, being able to model an entire hospital and the labs within that hospital, or even moving all the way down to energy, modeling power distribution grid, starting off with power generating stations, moving through substations all the way to residential power distribution. So all these verticals make great candidates for modeling as connected environments. So where does Azure Digital Twins fit in? Well, let's talk a little bit about the different elements here that you could use to feed information into your digital twins graph and then extract information back out of it. Starting with IoT Hub, that's our Azure service that allows you to connect devices to the cloud. So you can gather telemetry information from those devices and feed that information into your digital twins graph. You can also gather information from workflow integration sources such as logic apps, or even from your existing business systems and services such as a CRM system, ERP system, using our REST API. So with those different inputs, you can feed that into your Azure Digital Twins graph, which models your environment. And by building this graph, what you can do is then build your client app on top of the environment that is represented by this graph. And we'll talk about Azure Digital Twins in just a minute, but going through our flow here, you can subsequently extract information out of your graph and push that information into, for example, cold storage, or of course into Azure Digital Explorer. And we're going to talk about an example of this next with our Bosch building technology example. All right, so let's go into what is offered by Azure Digital Twins. And Azure Digital Twins is really built on 4 pillars here, which include an open modeling language, a live execution environment, input from IoT and business systems, and then output to TSI and storage and analytics. So the idea here is that by creating and modeling a connected environment, you have the ability to control the present, track the past, and predict the future. Now, when it comes to modeling, what we've done is we've created a new language called the Digital Twins Definition Language, or DTDL. It allows you to create models that then are instantiated as twins in your graph. And these models allow you to have a variety of different properties. So you can have telemetry properties for measurements that are coming from wearable devices, whether it's vibration, RPM, temperature, et cetera. And then you can store those incoming telemetry values as properties. You can also define relationships between different twins. And then the models are actually composable, so you can have inheritance. So one model can specialize other twins using inheritance. And one of the most powerful capabilities in DTDL is that you can define semantic relationships to connect your twins together in a knowledge graph. And usually these relationships are going to be in terms of contains or feeds, to give semantic meaning to how these different models, twins interact with one another. All right, so let's move to our second pillar here, which is the live execution environment. And once you created your models, and you're going to instantiate those models as twins in a graph. So in this example to the right here, we've modeled a railway network starting off at the highest level in our with a region, and that region has different assets within it, which include, for example, a zone, a switch, a train, and then a switch in this example is controlling tracks 2 and track 3. So one of the most powerful capabilities of Azure Digital Twins is the ability to query this graph here. And you can use all kinds of different search conditions when you're performing a query, including searching by property values or searching by the relationships between twins, as well as type information and even more. So now that we have this representation of our connected environment, the next step is to start feeding it with data from the real world. And that's where our different input sources come in, as we mentioned a little bit earlier here. So you can use IoT Hub to connect to devices in the real world and then feed the observations, the measurements from those devices to your twin graph, or you can also use IoT Edge as well. And by feeding that data from the real world, then you will keep your graph updated and in sync with the live execution environment. And again, I want to make a point here that Azure Digital Twins is not just about collecting information from real world devices, but also from all kinds of disparate data sources and breaking down those silos. So again, these could be more enterprise business applications that can also be used to feed data APIs. Looking at the last pillar of Azure Digital Twins, we have our output to different storage and analytics services here. So one of the things you can do within your twin graph, your live execution environment, is set up events that can be triggered as different twins interact with one another and feed those events to Event Grid or Event Hub or Service Bus to trigger notifications or actions by downstream services. You can also store data for long-term storage, or you can use other analytic services such as ADX to analyze and visualize the behavior of your twin graph as it changes over time. All right, well, that wraps it up for a brief introduction of Azure Digital Twins. And at this point, I'd like to hand it off to Andres and Habib from Bosch, who are going to be talking about a real-world use case using Azure Digital Twins and Azure Data Explorer for managing smart buildings.
Thank you, Taylor. My name is Andreas, and I'm the CTO with Bosch Building Technologies. Today, we want to talk with you about the power of digital twins and semantic data explorations for building operations. So this is obviously an IoT topic, and we will show you how to actually project physical structures and systems to semantically models powered process executions and gain analytical insights for highly efficient and transparent operations. So our vision at Bosch Building Technologies is very clear. We run a program where we are all about building intelligence as a services to understand buildings and their operations, to sustainably also care about the environmentals. So empower these complex physical systems to be intelligently operated with a high level of transparency and valuable insights is the result that we gain out of this to operate these systems highly efficient. So my friend Habib is going to set some business context for us, what buildings that are.
Thank you, Andreas. And hello, everyone. My name is Habib, and I'm part of the strategy group of Bosch Building Technologies. Today, Bosch Energy and Building Solution provides services mainly for owners and operators of buildings. As an integrator for security and life safety systems, we help our customers to protect their assets. Our building automation systems solve operational challenges in a building, and our energy managements are effective when energy efficiency and carbon footprint reductions are the objective. These solutions, even if you provide them for the same customers, are deployed in a state-of-the-art fashion, which means you're talking about rather siloed and domain-specific solutions that are designated for a particular use case only. With Climatech, our building technology subsidiary in the US, we are proudly serving our customers in the Southwest and New York area. Our headquarters, located in Phoenix, Arizona, is a perfect location to give you an impression of what it takes to efficiently and comfortably operate office spaces. It's also our real-world laboratory where we operate a representative cross-section of all sorts of building technologies that was introduced over the years. So we likewise face the challenges that everyone else faces of our customers who have to operate buildings that grew over years in many, many very different ways. The challenge is that these systems are rather intransparent and they don't provide that insight that you need in order to run them efficiently. You need experts that can help you manage this black box. What we want to offer is a much more transparent solution, more proactive and even prescriptive, and ideally operator friendly. To get to a building and a building system so beautifully transparent, we would have to have a contextual understanding of a building and of all its components. In other words, create and operate a digital twin of a building and all its systems. When considering a building lifecycle, we find these different phases. And during these different phases, there are also different digital twins. They're all valid in their own phase. The phase that we are talking about is the operational and maintenance phase. And this is basically the longest time that a building is in operation, where we need to have a system supporting it. Imagine this being a section of the Climatech headquarters you just saw in the video. It's a typical office space with different working areas, meeting rooms, and hopefully they are connected through doors and hallways. The heating and ventilation system, in short HVAC, usually consists of a variety of electromechanical pieces distributed throughout the building and on top of the building. A state-of-the-art building automation system supervises and coordinates this and takes care of the desired room conditions. So Andreas, please show us how we get from this reality to a digital twin.
Thanks, Habib, for setting up the context for us here. So obviously, to capture these real-world physical structures, these kind of model is what will empower us to get to all of the understandings of these complex activities and interplays of those systems. So if you look at these kind of systems here, you see that there is the building itself, then we have obviously the structure of the HVAC system. So, and both are being described in these in Azure Digital Twins. We call the digital twin definition language, which is a JSON LD kind of encoded thing. And together with the real structure of the building and the building automation system, if you like the topology of it, these combined and instantiated and being brought into an execution environment, Azure Digital Twin services in that context, is what makes the digital twins for us in the operation piece. And then, of course, we need to connect equipment and sensors so that the thing of connectivity comes to shine by using modern IoT protocols such as AMQP or MQTT HTTPS, connecting them to the cloud. So we entering the area of IoT hubs, obviously, and this is where the whole Azure IoT stack comes to shine as well. And so if we have different kind of building structures, university offices or hospitals, we still reuse these once described semantic elements in this kind of ontology space. And you see the space and the HVAC ontology combined here in that example, but we don't stop there. At Bosch Building Technologies, we serve 3 big domains, as Habib elaborated already in this building context. One, of course, is the building automation space. The other one is energy management, and the third one is security and life safety. So, of course, we are about to define these semantic standard models for our operations for all of those domains. And this is also what is the power of this approach to reuse these semantic models once you have to find them. So to give you a glimpse of an idea what this really means in reality, we're looking at a first IoT business service. That is how we call these babies in our Building Intelligence as a Service program. And it's all about to get real insights about this HVAC system. And if I drill into that system map, you now actually see the headquarters of Phoenix, Arizona that we saw in the video, which consists of 4 wings, A to D, and we have projected the HVAC system into that. So this is the power of 2 domains already, the space domain itself and the HVAC domain projected into this. And what we see here, there's an air handler unit, there is a chiller plant. We get real life data coming out from the underlying Azure Digital Twin service instance that's being powered by our 2 kind of semantic models. And I can see that the AHU C3 here obviously has an issue. So we get this real-time data from the equipment, and I can now drill into this kind of detected insight. So we see that this AHU has a deviation from a set point discharge temperature. It obviously has some business impact, and if I drill further into this, I will now see the time series behind that, and that's powered by the Azure Data Explorer. And I can even go further and drill deeper into this, and I can see the temperature, the pressure, and the carbon dioxide kind of time series. I can take away the forecast. And now I see the detected kind of insights that is being powered by the combination of the Azure Digital Twin graph plus the Azure Data Explorer. I can even actually have a look what Azure Data Explorer actually shows in terms of what it thinks the anomalies have been. And you can actually see it's close to the insights that we, with our domain expertise, actually detected. And so to give you a glimpse about these ontologies, what we have done is we created these ontology management services on top of ADT. So you see actually the Bosch Building Technology semantic models. We have a basic ontology, we have spaces, and obviously we have an HVAC one. And we even have version and dependency management built in here. And if we look into one of those ontologies, you will land into a GitHub repo that we will make later public as well. And you can see here, this is, for instance, the description of an air handler unit by the power of Azure Digital Twins and DTTL. So this is the air handler unit, and this is, JSON LD encoded. encoded. And this is, if you like, the vocabulary of the goodness of this kind of domain expertise captured, and we call this the Bosch Building Technologies Ontology Central. That's once we open this up later, then people also can contribute into this if they like, and create their own ontologies and publish it in here. And I can actually get a live view of this digital twin graph by connecting this service instance and looking at the tool that's called Azure Digital Twins Explorer, which is open source and available at GitHub as well. You can actually go here and you see the deployed model on that service instance. So here you see the AHU handler model again at its full glorified beautifulness. And I can see here at the moment I have a one node here selected that is an air handler unit C1, and we're getting real-time informations from the system. So if I just, for the sake of it, go to this air handler unit C3 that we just saw has obviously an issue, we can now in real time get the graph elements, and we see the sensors connected to that piece of equipment. And the AHU C3 obviously has 7 insights. And one of them, if you remember, was this AHU discharge temperature deviation. And that obviously is really true. So this is being powered by the underlying time series data that's being served by Azure Data Explorer. So you see here what we use internally. Obviously, we use the power of the digital twin graph query language plus all of the historians, the time series, and the built-in kind of analytic functions serves the time series decompositioning purpose and gives you forecasts as well as the anomalies here detected in the system, right? And so this is all powered by Azure Data Explorer. So here you can see once we actually change the set point to a lower value, and airflow actually arises until the temperature set point has been met. So this is all a live kind of experience that's being powered by Azure Digital Twins as well as Azure Data Explorer, and of course the connectivity to the building automation equipment, the chillers and the AHUs is being served also by Azure IoT Hub. So architectural wise, if you look under the covers, it looks like this kind of like solution architecture, kind of conceptual. So of course we have the equipment connected via gateways to the cloud gateways, which is an Azure IoT Hub. And then we actually let the informations flow into the Azure Digital Twin service instance, being powered by our ontologies in the repository. We also can command and control so that we can recalibrate and recontrol the equipment so that it actually does not consume unnecessary energy, does not cool a building if there are no people anymore in the building, and things like that. And then you see also that we let these informations flow semantically pre-qualified into the equipment time series, which is ADX. We also use building analytics. Sorry for that. We also use building analytics in order to do this cold kind of analytic perspective after the fact. So if you like, we use the power of ADX for online analytics, so for the real hot analytic perspectives, and also for the warm analytic perspectives, and for the far more off kind of colder analytic perspective, we're using also Azure Databricks in that regard. So you see also the pipelines here that are actually using the topology information in one of the encoded kind of topology structure information to actually onboard the building and instantiate a digital twin. And we have APIs, and then we actually provide these cockpits that you've seen. So the key takeaways here is, for us, building automation systems are really, really complex to operate, and they're quite labor intensive, and they require a lot of domain expertise to set up and configure. And the power of the models and the standards thereof actually brings really transparency and efficiency into the operations for us. This is a high value, and the combination of digital twins with intelligent data exploration enables these system insights and analytics for real predictive and prescriptive operations. So this is a real service that you've seen. We are rolling this out as we speak to pilot customers, and that's all that we have for you today. We say thank you a lot for watching this, and all the best for you.
What an amazing demo by Andreas and Habib. Thank you for sharing your journey. Your team has done an amazing job leveraging IoT Hub, Azure Data Explorer, and Azure Digital Twin in building your SaaS solution. Thank you. So we just talked about 2 case studies today. Bosch, who's using Azure Data Explorer for smart building technologies, and Hilo for energy management. These are just two examples. We are seeing success stories across the industry are leveraging Azure Data Explorer for building their IoT analytics solution for their internal use as well as external building external SaaS offering, both single tenant and multi-tenant mode. So the few takeaways I want to call out here. Consider Azure Data Explorer for building your IoT analytics. It offers you near real-time ingestion from IoT Hub, Event Hub, Data Lake, and so on, and SDKs, of course. It has built-in time series, machine learning capabilities, has faster query performance, and can handle really large-scale data, both on ingestion side as well as query side. It has big data and partner integrations that makes your life easy while you are building solutions and gives you deep control of your data sources, data schema, data lifecycle, and the cost of your solution. So definitely consider it for your scenarios. Here are some reference links that you may want to take a note of. It's a documentation, tech blogs, IoT reference architecture, and so on. And we host Ask Me Anything every month. The next one is going to be on December 2nd, and the link is posted on the slide here. With that, thank you for attending this session, and we're going to stay back until the end of the session for any Q&As. Please continue to ask questions on the chat window. Thank you.